So when we're using scientific notation, we're going to be only concerned with powers of 10. So every number written in scientific notation has a coefficient with one digit to the left of the decimal point multiplied by an exponential term, which is our power of 10. When 10 is raised to a positive power, then its decimal equivalent is a number 1 followed by as many zeros as the power. So 10 to the 0, we get 1 followed by 0 zeros. 10 to the 2, 1 followed by 2 zeros, and so forth. This is pretty familiar to most people. When 10 is raised to a negative power, we always end up with a number that is less than 1. So we can remind ourselves of this because 10 to the negative 1 really means 1 over 10 to the 1 or 1 over 10, and so that's going to give us a number that is smaller than 1. So what does our number look like in decimal form versus as a power of 10? Well, when we have a negative exponent, the absolute value of the power of 10 is always equal to the number of spaces that we need to move the decimal point to get 1. So in this case, I'd have to move the decimal point 1 space to get 1. So that corresponds to 10 to the negative 1. In this occasion, I'd have to move the decimal point 1, 2, 3 spaces to get 1. So therefore, we have 10 to the negative 3. And that's the same for any of our negative powers of 10. So you want to practice being able to flip backwards and forwards between the power of 10 and the decimal number. Sometimes this is said to be written in conventional arithmetic form when it's not written as a power of 10. So a little bit of language. A single power of 10 is an order of magnitude. So if something is one order of magnitude bigger than something else, then that's 1 power of 10 bigger. So 10 to the 4 is 1 order of magnitude bigger than 10 to the 3. And similarly, if something is a power of 10 smaller than another number, then it's 1 power of 10 smaller. So here we have an example here, 0.001, or if we want, that would be 10 to the negative 3, is 1 order of magnitude smaller than 0.01, which is 10 to the negative 2. Little tricky there writing with the mouse. But if you think about this for a little while, you get used to that language. So it's real easy to convert between scientific notation and regular decimal or arithmetic notation. There's really only 2 rules. First of all, you have to figure out what your coefficient is, and that's pretty easy. You take your decimal number and you move the decimal, you take your conventionally written decimal number and move the decimal point so that there is only one non-zero digit to the left of the decimal point. So that's really kind of very easy. The direction that you move your decimal point will depend on whether you have a small number or a big number. Now you have to figure out the size or the absolute value of your power of 10, and that's pretty simple. It's equal to the number of spaces that you moved your decimal point. So if your decimal number was less than 1, you will have a negative exponent, and if your decimal number that you began with was greater than 1, then your exponent is a positive number. So really 3 things going on. Get your coefficient, then get the size of the value of your power of 10, and then decide if your power of 10 needs to be a positive number or a negative number. So here's a few examples. We've got 5015, so I immediately know that this is going to have a positive power of 10. And in order to get my coefficient, I need to move my decimal point 1, 2, 3 spaces. That gives me my coefficient. And then because I moved my decimal point 3 spaces, my power of 10 is 3. And because I started with a big number, it's a positive 3. So 5.015 times 10 to the 3 is my number in scientific notation. Okay, here's a small number, a number that is less than 1. So to get my coefficient, I'm going to move my decimal point 1, 2 spaces to the right. That gives me a coefficient of 1.22. Because I moved my decimal point 2 spaces, I'm going to have a value for my coefficient of 2, and it needs a minus sign because I started with a small number. Now, what you want to recognize is that the number of significant figures in your coefficient is always equal to the number of significant figures in the number that you started with. So here we have decimal notation with 1, 2, 3, 4 significant figures, and here we have scientific notation and our coefficient has 1, 2, 3, 4 significant figures. Down here, our decimal number has 1, 2, 3 significant figures, and then our coefficient has 1, 2, 3 significant figures. Scientific notation always has a decimal point, so trailing zeros always count. There are never any leading zeros in scientific notation because we always make certain that the digit to the left of the decimal point is a number that is greater than 0. So in scientific notation, only significant figures are included in our coefficient. There's no leading zeros that don't count, and there's no trailing zeros that don't count in any of our coefficients. So that makes it really nice for expressing a number correctly to the right number of significant figures. So for example, if I want to write 1000 to one significant figure, I don't have to worry about overbars or decimal points. I can just put a 1 times 10 to the 3. There's one significant figure here in my coefficient, therefore my number has one significant figure. If I'd like to write this to two significant figures, I just make sure that my coefficient is written to two significant figures, so I just put an extra 0 there. That's a lot easier than writing an overbar, especially when you're typing stuff up on the computer. If I want to go out to three significant figures, I just have to include 2 zeros after my decimal point. And again, that's a little easier than doing the overbar above 2 zeros, and I can continue on for as many significant figures as I want. One thing that isn't so easy with scientific notation is deciding the uncertainty associated with my number. I look at the uncertainty in my coefficient. That's pretty easy to figure out what the plus or minus is there, but I must remember to get the true uncertainty of my number to multiply by the coefficient. So the overall uncertainty is my uncertainty in the coefficient multiplied by my exponential term. And so that's kind of, it's a little more clunky than when we write numbers in decimal notation. So if I was doing these guys, I'm just going to pop up my calculator in a moment, I have to work out what my uncertainty is here. So this number here, my uncertainty in my coefficient is going to be there, plus or minus 0.001, but then I've got to remember to multiply that by 10 to the 4. So plus or minus 0.001 times 10 to the 4, and that gives me an uncertainty of plus or minus 10. So similarly here, the uncertainty in my coefficient is plus or minus 0.1, but I have to remember to multiply it by 10 to the 5. So 0.1 times 10 to the 5 gives me plus or minus 10,000, or you could write that as plus or minus 10 to the 4 if you wanted to. Okay, so similarly here, we've got plus or minus 0.1 in my coefficient, and then I've got to remember to multiply that by my exponential term. So 0.1 times 10 to the minus 1 gives me plus or minus 0.01, and if I wanted to, I could write that as a power of 10. So it's important to learn how to read numbers that are written in scientific notation, and it's also important to learn how to enter them into your calculator. Most calculators have a means for doing this, and in the next section I'll show you how we're going to do that. You need to figure out how to use scientific notation in your specific brand of calculator, and a good way of doing that is just kind of look up some YouTube videos that are specific for your particular calculator that you have. I'm going to show you how to do it on a TI-84, which is one of the more popular calculators that people have in our class. So now we're going to learn how to add, subtract, multiply, divide using in scientific notation, and how to enter that math into our calculator. So let's have a look at some some multiplication problems here. So sometimes these numbers are so big we could never convert these to decimal notation and enter our answers in that way. But I'm going to kind of show you how to use the scientific notation feature on your calculator, and we'll also be focusing on expressing things to the correct number of significant figures. So when we're thinking about significant figures, we just have to think about the number of digits that are in our coefficient here. So in the first problem here, we're multiplying two numbers together that each have 3 significant figures. So let's get my calculator up, and I need to get my taskbar, and there we go, there's my TI-84. I have to turn it on. It always works better when you turn it on. And away we go. So I'm going to start entering into the calculator 5.85, second function e minus 9. That's my first number there, multiplied by 4.25, second function e to the 6, and then enter. And there it is there, it returns my number. Now I want to be a little bit careful here. It says express the answer in scientific notation. So I want to change my mode to be scientific notation. So I'm going to go mode, and then I want to move over one to scientific, enter, and then I'm going to quit back, and when I get it to display my answer now, my calculator just moved. It wants my calculator really badly, wants my calculator on that side. It displays it in scientific notation, and I've just got to remember that I want to round this off to 3 significant figures. So that's going to be 2.49 by 10 to the negative 2. So when I come back here, there we go, 2.49 by 10 to the negative 2. So it's a little awkward for me to show everything on the screen that I want to, but you get the idea. Okay, so let's do another one. 5.4326, second function e to the 19. That's a really big positive number, times 2.1000, second function e minus 3. That's a small number, so enter. It's going to give me the calculator answer. We've still got it in scientific mode, so it's going to give it to me in scientific notation. And I've got to think about how many sig figs I want here. 1, 2, 3, 4, 5. We got 1, 2, 3, 4, 5. So I need to round this off to 5 significant figures, so that would become 1.1408 by 10 to the 17. So we've got a big number there. Okay. All right, let's try one more, and then I'll leave you to do that. You can pause the video and try a couple in your own time. So here we go. 7.999, second function e to the 2, times 1.2. You don't have to put the 0 in there, it's not going to change the value. E minus 3, and enter. So there I am, 9.5988 by 10 to the minus 1. So how do I want this as far as sig figs can go? 4 sig figs, 3 sig figs. So therefore my answer needs to be to 3 significant figures. So this is going to end up becoming 9.60 by 10 to the minus 1. All right. So that's the first 3 there. I'll leave you to do the remaining couple on your own. Okay. All right. So let's just move on. So division is done the same. The nice thing about when you use the scientific notation feature on your calculator with the division is you don't have to put things in parentheses. So please get into the habit of using the E button on your calculator and not entering in times 10 to the power of every time, because that can lead to some pretty big errors if you happen to do it incorrectly. The most important thing is that whenever you are dividing, if you have multiple things on the bottom line of your fraction or on the top line of your fraction even, then they need to be in parentheses. Now, when we use the E button, we avoid that need though. So I'll just do the first one, 5.85. Second function, E minus 9. Divide 4.25. Second function, E to the 6. And then enter. And there's my number there in scientific notation. And I've got 3 significant figures here, 3 significant figures here. So I'm going to round this guy off, 1.38 by 10 to the minus 15. I'll do this the wrong way now. If I enter this in 5.85 times 10 to the power of minus 9 divide, we've got to back up one. That's a little, I want to delete that. Okay. There we go. Divide. You can already see that it's kind of clunky not to use the E button. 4.25 by 10 to the power of 6. You'll actually see that I get a different answer. You see, I'm way out on this guy here. So it doesn't really kind of quite do what we were imagining when we do it that way. Okay, so here we go again. 5.4326. Second function, E to the 19. Divide 2.1. We don't need all those zeros. Second function, E minus 3. And enter. There we are. Okay, 2.58695238 by 10 to the 22. So what we got to do now is we've got to decide how many sig figs we need. This guy's got 5 sig figs. This guy's got 5 sig figs. So that answer there will need 5 sig figs. So we'd have to round this off here to 5 significant figures. So we're going to round it off out here. Okay. All right. I'll leave you to do the last 3 there, and just make sure that you're getting consistent answers, and you're getting them, the consistent correct answers, and the answers are actually available. I'm just going to pop those up now for you. So here are the answers for all these problems. Okay, so work through that and make sure you can get what you need to happen. So adding and getting the correct significant figures is a little tricky because we have our difficulty with working out what is the uncertainty in our measurement. So applying our significant figures rules is a little tricky. The key thing is this: you want to adjust the coefficients on one of your numbers so it matches the other one, and then you can add your terms. So I'll show you what we've got going on here. So here we've got 2 numbers that we're adding. They're written in scientific notation, and what we want to know, how do we need to round this guy off? So 2.05 by 10 to the 2 plus 1.34 by 10 to the 1. And what you see is these guys have different exponential terms. So I'm going to adjust my number here, this guy, so that it has the same coefficient as my other number. And so here we go. I've left this guy alone, and now I've adjusted this one so it is multiplied by 10 to the 2. And so now I can evaluate easily what the uncertainty is in my coefficients. And so the uncertainty on this guy is plus or minus 0.01, and the uncertainty on this one is plus or minus 0.001. So when it comes time to round this the answer I get from my calculator, I'm going to round my coefficient to 0.01, to the 0.01 position. So all I have to do now to complete this math is add these 2 coefficients together, and that gives me this value here, and that's going to be multiplied by 10 to the 2, and I round off to the 0.01s. Occasionally you'll do a problem like this where you add together 2 coefficients and you get a new coefficient, and it's either bigger than 10 or it's either bigger than 1, or it's bigger than 10 or it's less than 1. In which case you might have to change the value of the exponential term by 1 to get it into the correct scientific notation. Now that's not really an issue if you use your calculator set to scientific notation mode, because your calculator will always give you the answer to correct scientific notation. So you want to have a practice at doing some of these. I'm just going to pop the answers up rather than use the calculator. So here we go. We've got two numbers here, 5.85 by 10 to the 5 plus 4.25 by 10 to the 6. The first step here is that I'm going to adjust one of these guys so that the coefficients are the same. And I could either I'm going to make this one a little bit smaller, so I would make that 0.585 by 10 to the 6, and then I'm going to add to that 4.25 by 10 to the 6. So when I look at this and I'm thinking about the uncertainty, this guy has uncertainty out to 0.001, and this guy has uncertainty out to 0.01. So when I write the answer for this, I'm going to write it out to 0.01 by 10 to the 6. So I'm now all I have to do is 0.585 plus 4.25 by 10 to the 6, and I'm going to cut it off at the second digit after the decimal place. So I have to kind of manually figure out where I'm going to have my uncertainty. So here we go. Let's kind of bring this up here, try and put this somewhere. It's going to be 0.585 plus 4.25. So there it is, 4.835, and that would be by 10 to the 6. So 4.835 by 10 to the 6. But I know that I need to cut it off at 0.01, and so it's a little bit confusing here because what's following is exactly 5, and then this is an odd number, so odd numbers go over, so that would be 4.84 by 10 to the 6. So when you're adding, it's a little bit of work to figure out the uncertainty in order to be able to get your number to the correct number of significant figures. So I can definitely get a correct calculator answer. It's just I need to kind of do this longhand thing here to make certain that I know where to cut it off to the correct number of significant figures. So, you know, we can see similarly here, here's my big number, here's my smaller number. I'd be adjusting the coefficient of this guy to make the power of 10 to the 19, so it would be, and this number would end up being 0.2100 by 10 to the 19, and that, by considering these two numbers, that's going to tell me what my uncertainty would be. So it's a bit clunky doing addition and subtraction and rounding off to the correct number of significant figures in scientific notation. So you can have a practice at these. It's a little awkward, that's for sure. Alright, so that pretty much brings us to the end of chapter 2. So that's where we're at. And yeah, now it's going to be like full steam ahead into chapter 3. And we'll probably be done with chapter 3 by the end of this week.